March 15th, 1944. The morning mist clung to the muddy fields of Tunisia like a shroud, carrying with it the acrid smell of burnt metal and cordite that had become the signature perfume of war. Through the fog, the skeletal remains of Churchill tanks dotted the landscape, their turrets twisted at unnatural angles, their steel hulls bearing the violent scars of German 88mm shells. The silence was broken only by the steady clang of hammers against metal, where a lone figure worked with methodical precision among the mechanical graveyard. Captain Percy Morrell of the Royal Electrical and Mechanical Engineers stood knee-deep in the entrails of what had once been Britain's finest armour, his hands blackened with grease, his uniform a patchwork of oil stains and welding burns. Around him, dozens of seemingly hopeless wrecks told the story of the Desert Campaign's brutal arithmetic. 60% of the Churchill tanks bore damage to their turrets alone, their hulls intact, but their fighting spirit seemingly broken forever. What happened next would defy every conventional rule of military engineering, challenge the very foundations of tank design philosophy, and transform a desperate field mechanic into one of the most ingenious problem solvers in military history. But more than that, it would prove that sometimes the greatest victories come not from following orders, but from breaking them entirely. And that was the moment the entire war shifted, though almost no one realized it at the time. This video examines published sources for educational purposes. Interpretations are attributed. No claims are asserted as fact without citation. Before we uncover today's secret from the pages of military history, if you enjoy exploring the hidden stories, decisive battles, and overlooked moments that shaped our world, please take a moment to like this video and subscribe for more know in the comments where you're watching old wartime histories. And let me from. I'm always amazed how these memories of the past connect us across so many corners of the world. The story begins not with heroic charges or strategic masterstrokes, but with a problem that was slowly bleeding the British armour forces dry. Every morning in the Tunisian desert brought fresh casualties, and every evening brought fresh despair. The Churchill tanks, pride of British engineering, were arriving at repair depots faster than they could be fixed or replaced. The mathematics of attrition were inexorable and terrifying. According to military records from the North African campaign, the British were losing tanks at a rate that would soon render entire armoured divisions combat ineffective. The German anti-tank guns, particularly the feared 88mm cannons, had found the Churchill's weakness with surgical precision. Time and again, high-velocity shells would strike the recessed mantlet area, where the gun mount created a natural shadow in the desert sun, providing German gunners with a perfect aiming point. Captain Morrell had witnessed this pattern of destruction firsthand during the battles around the Majorda Valley. The bright North African sun, which should have been an advantage for Allied forces, was instead illuminating their doom. The Churchill's design, perfectly for the grey skies adequacies of Europe, became a liability under the merciless clarity of desert warfare. But what separated Morrell from his colleagues wasn't just his mechanical aptitude. It was his refusal to accept the conventional wisdom that declared these tanks beyond salvation. While other engineers saw scrap metal, Morrell saw possibility. While official doctrine called for writing off damaged vehicles, Morrell began to envision something unprecedented. The revelation came to him during one of those endless desert nights when the temperature dropped 40 degrees and the silence was broken only by the distant rumble of German artillery. Morrell was cataloguing the damage to a particularly battered Churchill when he noticed something that would change everything. The turret was destroyed, yes, but the hull was intact. The engine ran smoothly, the tracks were functional, the armour was sound. Nearby sat the burned-out hulk of an American Sherman tank, its crew long since evacuated, but its 75mm gun mount surprisingly undamaged. The Sherman's external mantlet, specifically the M34 type, was everything the Churchill's wasn't. Where the British design created shadows, the American mount provided additional armour protection. Where the Churchill's recessed gun created vulnerability, the Sherman's external offer a mounting strength. But what if the real objective wasn't salvaging individual tanks, but creating something entirely new? Records from the period indicate that Morrell began his experiments in secret, working by lamplight in a makeshift workshop constructed from salvaged materials and sheer determination. The technical challenges seemed insurmountable. The Sherman's 75mm gun was designed for left-handed loading, while British tanks used right-handed loaders. The mounting systems were completely incompatible. The weight distribution would require extensive modifications to prevent the hybrid tank from becoming top-heavy and unstable. Most daunting of all was the fact that what Morrell was contemplating had never been attempted before. Military doctrine called for standardized equipment, predictable maintenance schedules, and approved modifications. What he was planning would violate every regulation in the book. Yet night after night, Morrell continued his calculations. He measured gun mounts and turret rings. He studied ballistics tables and armor thickness specifications. He calculated weight distributions and center of gravity adjustments. Slowly, impossibly, a solution began to emerge from the chaos of destroyed machinery. The breakthrough came when Morrell realized that the problem wasn't just mechanical, but philosophical. Everyone was trying to repair the Churchill tanks to their original specifications. But what if those specifications were fundamentally flawed for desert warfare? What if the answer wasn't restoration, but transformation? According to declassified documents from the period, Morrell's first successful conversion took place in a bomb-damaged warehouse outside Tunis. Working with a small team of trusted mechanics, he carefully removed the Churchill's damaged turret and began the painstaking process of widening the mantelet hole to accommodate the Sherman's gun mount. The work required precision that bordered on artistry. Every cut had to be perfect, every weld flawless. A single mistake would render the entire tank unusable. The Sherman's 75mm gun had to be rotated 180 degrees to accommodate the British crew positions, then carefully inserted complete with its M34 mount. The gun was then welded in place, creating what was essentially a new breed of tank. But the technical challenges were only the beginning. The modified tank required a counterweight in the rear turret to compensate for the increased size of the armament. Space had to be created on the left side of the gun for the Sherman's coaxial machine gun. The firing controls had to be completely adapted to work with the inverted gun system. And someone on that maintenance crew already knew this experiment would either revolutionize British armor or end their careers. The first test firing took place at dawn on a range outside the main depot. Morrell himself climbed into the commander's position of his hybrid creation, his hands steady on the controls despite the magnitude of what he was attempting. If the modifications had weakened the turret structure, if the weight distribution was wrong, if any of 100 different calculations were incorrect, the gun could tear itself apart and kill everyone inside. The order came through the intercom system: load high explosive. The loader, a young corporal from Yorkshire, slammed the shell into the breech with practiced efficiency. The gunner, initially skeptical of the hybrid system, found the controls responsive and precise. Target acquired, range estimated, ready to fire. The moment of truth arrived, with a thunderous roar that echoed across the desert like the voice of an angry god. The 75mm shell streaked toward its target with devastating accuracy, striking dead center and obliterating the practiced target in a shower of sand and metal fragments. The turret held. The gun mount remained solid. The impossible had become reality. Yet what happened next would prove even more remarkable than the successful test. Word of Morrell's achievement spread through the fief and maim same iri tree in size maim say im supper. Me Riu ar she di ray bira bras with the mutts we a ray re ye we the speed of wildfire. Mechanics who had been writing off damaged Churchills as total losses suddenly possibilities saw they had never imagined. Engineers, the limitations who had accepted of British tank design, began to question their assumptions. Within weeks, Morrell's secret experiment had become an unofficial priority. The hybrid project tanks combining British armour with American firepower began appearing on battlefields across North Africa with devastating effect. German anti-tank crews, accustomed to the predictable patterns of Churchill tank attacks, found themselves facing an enemy they couldn't identify or counter. But the most significant impact wasn't tactical, but psychological. For the first time in months, British tank crews were advancing with confidence rather than resignation. They knew they were driving machines that could match German firepower while maintaining the legendary durability of British engineering. However, declassified documents suggest that not everyone was pleased with Morrell's innovation. Military bureaucracy rarely embraces unauthorized modifications, regardless of their effectiveness. Questions were being asked at headquarters about procurement procedures, warranty obligations, and chain of command protocols. The irony was perfect and devastating. While Morrell's hybrid tanks were proving themselves in combat, saving British lives and turning the tide of armoured engagements, the very success of his innovation was creating administrative problems that threatened to shut down the entire programme. And in the corridors of military headquarters, decisions were being made that would determine whether Morrell's genius would be recognised as the war-winning innovation it was, or buried as an embarrassing violation of proper procedure. The mad mechanic who had turned broken tanks into engineering legends was about to discover that sometimes the greatest enemy isn't on the battlefield, but behind a desk marked authorized personnel only. The weight of administrative machinery, however, was nothing compared to the pressure building from an unexpected quarter. As Morrell's hybrid tanks began appearing in classified battle reports, intelligence analysts at German Army Group Africa headquarters were encountering something that defied their comprehensive understanding of British armoured doctrine. The photographs arriving from forward reconnaissance units showed Churchill hulls mounting what appeared to be American guns, but the technical specifications made no sense according to any known Allied production schedule. Oberst Heinrich Müller, Chief Intelligence Officer for the 21st Panzer Division, had spent 3 years cataloguing every variant of Allied armour. His files contained detailed schematics of Churchill tanks, Sherman tanks, and every conceivable modification attempted by field workshops. Yet the vehicles appearing in reconnaissance photographs represented something entirely outside his experience. According to intercepted German communications from the period, Müller's initial assessment dismissed the reports as identification errors by inexperienced observers, but the pattern persisted. German anti-tank crews, veterans of campaigns from Poland to Stalingrad, began reporting encounters with British tanks that fired American ammunition. The psychological impact on German forces was subtle but profound. For months, they had developed successful tactics against predictable British armour. Now they faced an enemy that combined the durability they couldn't penetrate with firepower they couldn't match. Meanwhile, in a requisitioned olive oil warehouse outside Tunis, Morrell's operation had evolved from desperate improvisation into something resembling mass production. The success of the first conversion had validated his theory, but scaling the process required innovations that pushed military engineering into uncharted territory. Each Churchill-Sherman hybrid demanded 36 hours of continuous work by teams of skilled mechanics, welders, and armourers. The technical challenges multiplied with each conversion. No two damaged Churchill tanks presented identical problems, and the salvaged Sherman components varied depending on which American unit had abandoned them. Morrell's teams developed a classification system for damaged types, standardized mounting procedures, and created improvised tools that would have impressed Detroit assembly line foremen. Records indicate that by April 1944, Morrell's workshop was converting approximately 12 tanks per week, a production rate that rivaled some factory installations. The converted vehicles were designated as Churchill Mark IV NA-75, though this official designation wouldn't appear in military documents until months later. The crews who received these hybrid tanks began referring to them simply as Fireflies, a name that captured both their lethality and their ability to appear where least expected. Yet someone in the upper echelons of British command was beginning to ask uncomfortable questions about resource allocation and unauthorized modifications. The breakthrough that transformed Morrell's local innovation into a theatre-wide program came through an unlikely source. Colonel James Harrison, commanding officer of the 25th Tank Brigade, had lost 2/3 of his operational vehicles during the fighting around Longstop Hill. Facing the prospect of withdrawing his entire unit from combat operations, Harrison received an offer that seemed too good to be true. A Royal Engineers captain claimed he could return Harrison's brigade to full strength within 2 weeks, using tanks that official records had written off as total losses. Harrison's initial skepticism gave way to amazement as he inspected Morrell's workshop. The hybrid tanks looked unconventional, certainly, but their performance specifications exceeded anything in the British inventory. The 75mm gun could fire high explosive shells that British tank crews hadn't seen in months. The external mantlet provided armour protection that addressed the Churchill's most glaring vulnerability. Most importantly, these machines were available immediately rather than after months of waiting for factory replacements. The first combat test of Morrell's hybrids came on April 22, 1944, during the assault on Hill 609. Harrison's reconstituted brigade advanced against prepared German positions with a confidence that surprised both sides. German anti-tank crews, positioned to exploit the Churchill's known weaknesses, found their carefully plotted firing solutions inadequate against the modified vehicles. Unteroffizier Klaus Weber, a veteran gunner with the 21st Panzer Division, recorded his confusion in a letter discovered decades later in military archives. The British tanks moved like Churchills but fired like Shermans. Our range cards were useless. The shadows we targeted were wrong. These were not the same machines we had been fighting for months. But the true validation of Morrell's innovation came from an unexpected source. American liaison officers, observing the hybrid tanks in action, began requesting technical specifications for their own field workshops. The irony was perfect. American-designed guns mounted on British hulls were impressing American observers who had never considered the combination themselves. However, declassified documents suggest that success was creating its own problems. Military logistics systems, designed for standardized equipment and predictable maintenance schedules, struggled to support vehicles that existed nowhere in official inventories. Spare parts requests for Churchill-Sherman hybrids created administrative confusion that rippled through supply chains from Tunisia to London. And in the basement of the War Office, filing clerks were discovering that some innovations succeed despite the system rather than because of it. The administrative reckoning arrived in the form of Brigadier Sir Reginald Thornton Hughes, Inspector General of Mechanical Engineering for the Middle East Command. Thornton Hughes represented everything that Morrell's operation was not. Where Morrell improvised, Thornton Hughes demanded documentation. Where Morrell adapted, Thornton Hughes required authorization. Where Morrell created, Thornton Hughes audited. The inspection that began on May 8, 1944, was intended to determine whether Morrell's unauthorized modifications violated military regulations, procurement protocols, and safety standards. Thornton Hughes arrived with a team of technical experts, administrative officers, and enough paperwork to reconstruct the entire North African campaign. What he found challenged every assumption about military innovation and field engineering. Morrell's workshop had achieved production rates that exceeded some factory installations while maintaining quality standards that surpassed official specifications. The hybrid tank showed lower mechanical failure rates than standard Churchill variants. Combat effectiveness reports indicated that units equipped with the modified vehicles were achieving tactical objectives that had been impossible with conventional armour. Yet none of this had been properly authorized, documented, or approved through established channels. From an administrative perspective, Morrell's operation represented a complete breakdown of military discipline and procurement oversight. From a tactical perspective, it represented the most successful armour modification program of the war. The interview between Thornton Hughes and Morrell, conducted on May 12th in a dusty office overlooking the Mediterranean, would determine the fate of an innovation that was already changing the course of armoured warfare. According to witnesses, Thornton Hughes opened with questions about authorization procedures and ended with requests for technical specifications. Captain Morrell, Thornton Hughes reportedly said, You have violated approximately 47 separate regulations, ignored proper procurement channels, and created a maintenance nightmare that will perplex logistics officers for decades." He paused, studying the combat reports spread across his desk. "You have also saved approximately 300 British lives and restored combat effectiveness to units that were essentially written off as losses." But what happened next would prove that sometimes the most important battles are fought not on battlefields, but in conference rooms where regulations meet results. The decision that emerged from that meeting represented a compromise that satisfied no one completely, but preserved what mattered most. Morrell's operation would be retroactively authorized under emergency wartime provisions. The hybrid tank program would be classified under Operation Whitehot, with technical specifications distributed to selected field workshops throughout the theatre. Production would be expanded to meet demand from units that had witnessed the converted vehicles in action. Most significantly, Morrell himself would be promoted to Major and awarded the Military Cross for exceptional initiative in developing battlefield modifications that significantly enhanced combat effectiveness. The official citation carefully avoided mentioning that those modifications had been unauthorized, unofficial, and administratively impossible. According to military historians, the Churchill-Sherman hybrid program ultimately converted approximately 200 tanks between March and June 1944. The success of these conversions influenced post-war tank design philosophy and established field modification procedures that remained in use for decades. The external mantlet design pioneered by Morrell's team became standard equipment on subsequent British tank variants. Yet perhaps the most lasting impact was psychological rather than technical. Morrell had demonstrated that innovation could emerge from desperation, that field engineers could solve problems that factory designers had missed, and that sometimes the most effective military equipment came from breaking rules rather than following them. The young mechanics who worked in Morrell's workshop returned to civilian life with skills and confidence that transformed entire industries. They had learned that impossible was often just another word for unauthorized, and that the difference between innovation and insubordination was usually measured in results rather than regulations. And somewhere in the archives of the Royal Electrical and Mechanical Engineers, there remains a file marked "Lessons Learned from Unauthorized Field Modifications" that continues to influence military engineering doctrine to this day. But Percy Morrell's triumph was about to collide with an IM force more placeable than German artillery. The British War Office had been watching. Lieutenant Colonel Archibald Pemberton Wells arrived at the Tunis depot on June 3, 1944, carrying orders that would either legitimize the most successful unauthorized program of the war or bury it beneath layers of military bureaucracy. His briefcase contained correspondence from the Ministry of Supply, technical assessments from the Royal Ordnance Factory, and questions that had been percolating through Whitehall since the first intelligence reports of Churchill-Sherman hybrids reached London. The meeting that would determine the fate of Morrell's innovation took place in a requisitioned schoolhouse overlooking the harbour, where Mediterranean sunlight streamed through windows that still bore the scars of German bombing. Present were Pemberton Wells, representing official authority, Morrell, defending practical innovation, and Colonel Harrison, whose combat reports had made the hybrid program impossible to ignore. According to declassified minutes from that meeting, Pemberton Wells opened with a state me forthi self anit aima say to me the captured the fundamental tension between military regulation and battlefield necessity. Gentlemen, we face a unique situation. Captain Morrell has achieved remarkable results through methods that technically constitute gross violations of procurement protocol. The question before us is whether success justifies circumventing established procedure. The irony was not lost on anyone present. While they debated administrative compliance, hybrid tanks were engaging German forces across Tunisia with unprecedented effectiveness. Radio reports arriving hourly describe successful engagements where converted Churchills had outfought superior numbers of German armour. The mathematics of war were writing themselves in favour of Morrell's unauthorised innovation. Yet Pemberton Wells represented more than bureaucratic obstinacy. Military logistics depended on standardization, predictable maintenance schedules, and approved supply chains. Each hybrid tank created a ripple effect of complications that challenged the entire support structure of modern mechanized warfare. Spare parts for non-existent vehicles, ammunition compatibility issues, training requirements for unfamiliar systems. But what happened next revealed something profound about military innovation under pressure. Pemberton Wells had come to Tunisia prepared to shut down an unauthorized program. Instead, he found himself witnessing the birth of a new approach to battlefield engineering. Morrell's workshop had evolved beyond simple conversion work into something resembling an advanced research of mechanics facility. Teams were developing standardized procedures for hybrid, creating technical manuals for maintenance protocols, and training specialists in the unique requirements of multinational weapon systems. The tour of Morrell's expanded operation lasted 3 hours and challenged every assumption Pemberton Wells held about field. Where engineering capabilities he expected improvised solutions, he found systematic innovation. Where he anticipated quality compromises, he discovered standards that exceeded factory specifications. Where he assumed logistical chaos, he witnessed organizational efficiency that impressed peacetime production managers. Perhaps most significantly, he met the crews who were taking these hybrid machines into combat. Tank commanders who spoke of confidence restored after months of tactical frustration. Gunners who described the satisfaction of finally possessing firepower adequate to their courage. Drivers who reported mechanical reliability that surpassed their experience with standard vehicles. The human element proved decisive in ways that procurement manuals had never anticipated. According to witnesses, Pemberton Wells's final interview with Morrell took place beside one of the converted tanks, its armor bearing the fresh scars of recent combat, but its crew preparing for another mission with calm professionalism. The conversation that followed would reshape British armor doctrine for the remainder of the war. "Major Morrell," Pemberton Wells said, using the rank that had been confirmed just hours earlier, "you have created something that officially exist cannot. These vehicles appear in no technical manual, follow no approved specification, and require maintenance procedures that violate established protocol." He paused, watching mechanics prepare another hybrid for its next mission. "Yet they work better than anything we have produced through proper channels." The decision that emerged from that conversation represented a revolutionary shift in military thinking about innovation and authorization. Rather than shutting down Morrell's program, the War Office would expand it. Operation Whitehot would become an official modification program with resources, personnel, and technical support provided through proper channels. The hybrid tank concept would be studied, refined, and potentially incorporated into future British armour designs. Most remarkably, Morrell's field workshop would serve as a prototype for mobile engineering units capable of major modification work in combat theatres. The improvised tools and techniques developed in a converted warehouse would influence British military engineering doctrine for decades. But the transformation went deeper than administrative recognition. Morrell had demonstrated that innovation could emerge from desperation, that field engineers possess capabilities that factory designers had never imagined, and that sometimes the most effective military solutions came from ignoring rather than following established procedure. The psychological impact rippled through every level of British armour operations. Tank crews who had resigned themselves to fighting with inadequate equipment suddenly discovered that improvement was possible. Mechanics who had accepted the limitations of standardized designs began questioning whether those limitations were truly absolute. Engineers who had followed specifications without question started considering whether specifications might be starting points rather than final destinations. Yet someone in German intelligence was beginning to piece together the implications of what they were observing. Oberst Heinrich Müller's final report on British armour modifications, dated June 28, 1944, represented one of the most perceptive intelligence assessments of the North African campaign. Müller had initially dismissed reports of hybrid tanks as identification errors. Weeks of accumulated evidence forced him to confront a more disturbing possibility. The British, according to Müller's analysis, had developed the capability to modify damaged vehicles into more effective weapons than their original specifications permitted. This represented not just tactical adaptation, but systematic innovation that could transform the balance of armoured warfare. German forces had developed successful counters to known British and American tank types. They possessed no effective response to vehicles that combined the best characteristics of multiple designs. More ominously, Müller's report suggested that the hybrid program indicated broader British capabilities in field engineering and battlefield adaptation. If they could successfully marry Churchill hulls with Sherman guns, what other combinations might they develop? Could they mount German weapons on British chassis? Were they experimenting with captured equipment to create entirely new categories of military vehicles? The psychological warfare implications were equally significant. German tank crews, accustomed to predictable enemy capabilities, were encountering opposition that defied their tactical training. The uncertainty created by facing unknown weapon systems was undermining the confidence that had sustained German armour superiority throughout the early war years. But Müller's most prescient observation concerned the strategic implications of battlefield innovation. Military doctrine assumed that equipment capabilities were fixed at the point of manufacture. The British hybrid program demonstrated that creative field engineering could continuously evolve weapon effectiveness throughout a campaign. This represented a fundamental shift from static to dynamic equipment doctrine that could revolutionize military logistics and tactical planning. However, Müller's warnings would prove prophetic in ways that transcended the immediate tactical situation. By July 1944, reports of British hybrid tanks were reaching German Army Group Centre, where preparations were underway for the defence of Western Europe against the anticipated Allied invasion. Staff officers studying Müller's intelligence assessments began to consider disturbing questions about their own defensive preparations. If British forces could successfully modify damaged vehicles into more effective weapons, what might they accomplish with access to captured German equipment? The Atlantic Wall defences included numerous examples of German armour and artillery that could potentially be turned against their original users. More significantly, the hybrid program suggested that Allied forces possessed field engineering capabilities that German doctrine had never anticipated. General Erwin Rommel, commanding Army Group B, responsible for coastal defences, reportedly expressed concern about the implications of British innovation for German defensive strategy. According to captured documents, Rommel's staff meetings in July 1944 included discussions of potential Allied use of captured German equipment and the need for more comprehensive destruction procedures when abandoning positions. The irony was perfect and devastating. A program that began as Percy Morrell's desperate attempt to salvage damaged tanks in Tunisia was influencing German strategic planning for the defense of France. Innovation born from scarcity was creating abundance of tactical options that challenged fundamental assumptions about military capability. Yet in the workshops scattered across North Africa, mechanics continued their patient work of transformation, unaware that their welding torches and cutting tools were reshaping the strategic calculations of generals and field marshals across two continents. The final validation of Morrell's innovation came from an unexpected source. American technical observers, initially skeptical of British field modifications, began requesting detailed specifications for potential implementation in Pacific theatre operations. The hybrid concept that combined British durability with American firepower had impressed officers who possessed access to the most advanced military technology in the world. Lieutenant Colonel James Patterson, U.S. Army Ordnance Corps, summarized the American assessment in a classified report dated August 15, 1944. The British field modification program demonstrates capabilities that exceed our factory production standards in several key areas. The integration of disparate weapon systems has been achieved with precision that surpasses peacetime manufacturing tolerances. Most significantly, the program has maintained production schedules that rival major industrial installations while operating under combat conditions. Patterson's report recommended immediate implementation of similar programs in American theaters, with particular emphasis on Pacific operations, where supply lines made equipment replacement extremely difficult. The techniques developed by Morrell's teams could enable American forces to create hybrid vehicles suited to specific tactical requirements without waiting for factory production and trans-Pacific shipping. But perhaps the most remarkable aspect of Patterson's assessment concerned the human factors involved in successful field modification programs. The British success appears to depend not just on technical capability, but on organizational culture that encourages innovation and accepts calculated risks. Our own field workshops possess comparable technical skills, but may lack the operational flexibility that enabled the British program to achieve such remarkable results. This observation captured something profound about the relationship between military innovation and institutional culture. Morrell's success had depended not just on his individual genius, but on a command structure desperate enough to tolerate unauthorized experimentation. American forces, operating with more abundant resources and established supply chains, might to replicate the creative desperation that had driven British innovation. The paradox would influence military engineering doctrine for generations. Sometimes scarcity created capabilities that abundance could never achieve. And in the basement files of the Pentagon, analysts were already studying the British hybrid program for lessons that would shape American military innovation throughout the remainder of the 20th century. By autumn 1944, the Churchill-Sherman hybrid program had evolved from Percy Morrell's desperate improvisation into an established component of British armour doctrine. Technical manuals had been written, training programs established, and production procedures standardized. The impossible had become routine. The unauthorized had become official, and the innovative had become institutional. Yet the most lasting impact transcended technical specifications and production numbers. Morrell had demonstrated that the gap between military regulation and military necessity could be bridged by individual initiative, creative engineering, and willingness to accept responsibility for unauthorized action. The mechanics, welders, and engineers who had worked in his workshops returned to civilian life with confidence that problems were solvable, that authority was questionable, and that innovation was possible regardless of official approval. The Churchill-Sherman hybrids themselves continued in service through the end of the European War, participating in the liberation of Italy, the invasion of southern France, and the final assault on Germany itself. Their combat record vindicated every risk Morrell had taken and every regulation he had violated. More than 200 vehicles that should have been scrap metal instead became instruments of victory, proof that sometimes the most important military innovations emerge not from drawing boards and factories, but from the desperate ingenuity of mechanics working by lamplight in conquered territories. But what they had really accomplished was something more profound than tactical success or strategic advantage. They had proven that warfare itself was not a matter of following prescribed formulas, but of reimagining what those formulas could become when necessity met imagination. The mad mechanic's legacy lived not in the specific tanks he had modified, but in the revolutionary principle he had established. Military effectiveness was not determined by what regulations permitted, but by what circumstances demanded and creativity could deliver. The ripple effects of Morrell's innovation extended far beyond the immediate tactical advantages gained in North Africa. By demonstrating that field modifications could exceed factory specifications, he had fundamentally challenged the relationship between military industry and battlefield effectiveness. The hybrid program proved that the most sophisticated military equipment was not necessarily the most effective, and that innovation could emerge from scarcity as readily as from abundance. According to post-war analyses conducted by the Royal Military College of Science, The Churchill-Sherman hybrid program influenced British military procurement policy for decades. The success of unauthorized field modifications led to the establishment of formal rapid prototyping programs within the Royal Electrical and Mechanical Engineers. These programs institutionalized the creative problem-solving approach that Morrell had pioneered under combat conditions. More significantly, the hybrid program demonstrated that military innovation could emerge from the bottom up rather than exclusively from the top down. While traditional military development relied on staff officers identifying requirements, engineers developing solutions, and factories implementing designs, Morrell's approach reversed this sequence. Field mechanics identified problems, developed solutions, and proved effectiveness before seeking official approval. This inversion of the normal innovation cycle would prove prophetic. Throughout the remainder of the 20th century, many of the most effective military technologies emerged from field modifications rather than planned development programs. From helicopter gunships in Vietnam to improvised explosive device countermeasures in Iraq, battlefield necessity continued to drive innovation in ways that peacetime planning could never anticipate. Yet perhaps the most profound impact occurred in the realm of military culture and institutional thinking. Morrell's success had demonstrated that individual initiative could overcome systemic limitations, that creative thinking could solve problems that conventional wisdom deemed impossible, and that sometimes the most important military victories were won not against enemy forces, but against the constraints of military bureaucracy itself. The mechanics who had worked in Morrell's workshops carried these lessons into civilian life, where they revolutionized manufacturing processes, automotive design, and industrial engineering. They had learned that specifications were starting points rather than limitations, that problems were opportunities for innovation, and that the phrase impossible usually meant unauthorized rather than genuinely unachievable. But what they had really accomplished was to prove that human ingenuity, when unleashed by necessity and guided by competence, could overcome almost any material disadvantage. In the end, Percy Morrell's story reminds us that the greatest innovations often emerge not from boardrooms or laboratories, but from the desperate creativity of individuals who refuse to accept defeat. His legacy lives on in every military engineer who looks at broken equipment and sees possibility rather than scrap metal, in every mechanic who understands that regulations are guidelines rather than absolute limits, and in every soldier who knows that sometimes the most important victories require breaking the very rules designed to achieve them. The Churchill-Sherman hybrids disappeared from battlefields after 1945, but their impact echoes through decades of military innovation. Today's improvised battlefield modifications, rapid prototyping programs, and field engineering initiatives all trace their philosophical ancestry back to a Tunisian warehouse where one determined captain proved that necessity and imagination could overcome any material disadvantage. What other stories of unauthorized brilliance remain buried in military archives, waiting for historians to uncover the individuals who change warfare by refusing to follow orders? We present these accounts with respect for all who served and suffered during these events, recognizing that behind every technical innovation were human beings whose courage and creativity shaped the world we inherited.